In this third and last lecture for the unit on molar conversion, we are going to talk about percent by mass. For this section, you are going to need your calculator. You are going to need your red, white, and blue periodic table. You are going to need a pencil or pen and paper. The assumption is that you know your polyatomic ions if you're in honors. And if you're in regular, you should have your orange and blue sheet with you. Okay? All right, so let's get ourselves started. What is the percent by mass of carbon in carbonic acid? Like I said, we're looking at the percent of an element in a compound. So first thing we have to do is we have to find what mass of that compound is that element, and then we'll multiply that by 100 to figure out what percent that denotes. First thing we have to know, though, is we have to know the formula for that particular compound. This compound is carbonic acid, and when we look at carbonic acid, we know that acid means that it is hydrogen. That's what all acids start with, hydrogen. And carbonic, this is the acid name of carbonate. Now you should know that the name of this compound then is hydrogen carbonate if hydrogen has a positive charge, and carbonate is CO3 negative 2, which if you're in honors, you should know by heart. You drop the sign, drop it down, switch and simplify, and the formula you get from this is H2CO3. So we now know the formula, which is H2CO3. The total mass you should be able to calculate by now. Hydrogen has atomic mass of 1, and there are 2 of those. Carbon has an atomic mass of 12, and there's only 1. Oxygen has an atomic mass, which rounds to 16, and there are 3 of those. So we put them in the calculator. Clear your calculator. Open parentheses, 2 times 1, just to follow the process, plus 12, plus, open parentheses, 3 times 16, close parentheses, is equal to, and we should get an answer that is 62 grams per mole, or the total mass of 1 mole of H2CO3 is equal to 62. What part of the mass is the carbon? Well, when we look at carbon, we know that carbon is 12 of the total mass of 62. So that is going to be 12 divided by 62, right? Because we want to know what part is just the carbon. So 12 divided by 62 is going to give us a 0.1935. But remember that this is the mass. So that's how many grams of the total 62 grams. So now we want to know, okay, what is the percent? Well, if I know that carbon is 0.1935 grams of the total, then percent simply means times 100, and that will give me my percent of carbon in carbonic acid, and that is going to be equal to 19% when you round it. Pause the video if you need to. Go back and replay this section to make sure you understand that, and then move on. Let's look at, this time we want to know the hydrogen in carbonic acid. Well, we already know the formula for carbonic acid is H2CO3. We know the mass of carbonic acid is 62 grams per mole. But this time we are going to look at the part that is just hydrogen, and that is 2 grams out of the 62. Well, 2 grams out of 62 is 2 divided by 62. So clear your calculator, put 2 divided by 62, and let's check and see if we have the right answer. Did you get 0.0322? If so, you're absolutely correct. Again, remember that's the number of grams out of 62 grams, but we want percent. So to calculate the percent of that, we would need to take our 0.0322 and multiply that by 100. Press the equal sign. So go ahead and do that and check back and pause, do that, check back and see if you got it correct. And your answer should be 3% if you round it. If you got that correct, you are doing just fine. If not, make sure you write your answers down and hopefully we'll have them answered by the end of this. All right, this last one. What is the percent by mass of oxygen in carbonic acid? Well, we know the formula of carbonic acid by now. We know the total mass of carbonic acid by now. So what I want you to do is I want you to figure out the part of the mass that is just oxygen, and I want you to figure out the percent of oxygen. Pause the video, and then press play when you're ready to check back. Well, this time we're looking at 42, which is the grams of oxygen in that total mass, out of 62. So that's going to be 48 divided by 62. Press the equal sign, and that is going to give you a mass of 0.7741. And then we're going to take that mass and find out your percentage. How do we do that? We take our 0.7741 and multiply it by 100. When we do that, that is going to give us a percentage of 77% to the whole number. If you got all three of those right, you are doing just fine. If you have questions, we're going to do another set, so hopefully that will answer them. Okay, the percent by mass of oxygen in phosphorus acid. This is another formula you should know, or we're going to go through with you. So we have phosphorus acid. This is one of those acid names that remember that special acid naming? Phosphorus, sulfur, and carbon become special when you make them into an acid. Instead of it being phosphus, it's phosphorus, or sulfus becomes sulfurous, or carbonus becomes carbonus. So those names change when it comes to acid. This is that special name. So we know the acid, though, is going to be hydrogen. Phosphorus, you should know, means that it's an ite, so it's phosphite. Okay, and that's how phosphite becomes phosphor. And so hydrogen phosphite, hydrogen is a positive 1, phosphite is PO3 negative 3. When you drop the sign, drop them down, switch and simplify, you get H3PO3. So there's your formula for phosphorus acid. Again, remember that when you're converting phosphorus, sulfur, and pretty much carbon, into an acid, we put the full name. Instead of phosphus, it becomes phosphorus. Okay? Just a little aside for you. Anyway, so we now have the formula for this, which is H3PO3. What is the total mass? We have 3 hydrogens at 1 gram per mole. If you look on your periodic table, phosphorus is 31 grams per mole, and we have 3 oxygens at 16 grams per mole. If we add them all up, that's going to give us 82 grams per mole. We're asking for the oxygen, So we're going to focus on the 48, which is the mass that oxygen contributes. So that is, there we go, 48 of the 82 grams. So 48 divided by 82. Use your calculator. 48 divided by 82, push your equal sign, and you should get 0.5853. But we want to know the percentage, so we have to take that 0.5853 and multiply that by 100. So go ahead and do that with your calculator. Press the equal sign, and your answer for that should be a 59% when you round it to the nearest whole number. Okay? This is phosphorus and phosphorus acid. We already know the formula. You already know the total mass. So what I want you to do is to pause the video and find out what part of the mass is just the phosphorus, and then convert that into percent, and then press play when you're ready to continue. Okay, so 31 of those grams out of the 82 is phosphorus, so that's 31 divided by 82, and when we do the math on that, that should make it equal to 0.378, and because I want the percent, I'm going to have to take that 0.378 and multiply it by 100. When I do that, you should have gotten 38% as a whole number. Again, if you're getting this, you're doing just fine. This time we're asking for hydrogen. Again, you know the formula. You know the total mass. Go ahead and calculate what the percentage of hydrogen is going to be. Pause the video and then come back and check yourself. The part that's just hydrogen are 3 grams out of the 82. That's 3 divided by 82 is equal to, when you do that on your calculator, you should get 0.0365. And the percent of 0.0365 grams of the total 82 is going to be 0.0365 times 100. Now here you got to be careful, because if we're rounding this to the nearest whole number, you're going to have 4%. Okay? Remember that this is going to wind up at 3.65%, and to round it to the nearest whole, it's going to have to be a 4% because that 6 is by that 3. Okay? And that ends your last lecture on molar conversion. Have a great day.